This company here is spending over $1 million on hiring agent orchestrators. So if you're not fully bought into working with AI at the next level, I think you should watch this video of me walking through this company and their challenge. The company is called Firecrawl, and they've raised over $14 million to help users have their agents work with real web data easily. So just like you and I might have used Google, AI agents are going to interact with the web in a different way, in a way that you and I don't expect and probably don't actually use the web. The challenge itself consists of 3 different levels that last 4 minutes in total. Through those 3 levels, you've got to answer 60 questions. The levels are broken down into 3 distinct agent categories. The first is Orchestrate, the second is Explore, and the third is Build. Now, I've already beaten this challenge, and if you're looking to take it as well, then I suggest you pause this video before moving on. Let's look at the 3 challenges now. Challenge 1 is all about orchestration. So when we enter this challenge, we're going to see that we've got a list of 25 JavaScript algorithms that we've got to somehow solve in less than 60 seconds. We can see that there's a range of difficulty from easy to very competitive, and we can also see that not all the text is expanded. So there's imperfect information to the actual user, me. We can also see that there seems to be a system verification, a system prompt to kind of inject into our AI system, and it doesn't even have the full text here. So we've got 25 questions which we've got to solve with varying degrees of difficulty and various malicious or adversarial challenges from the competition provider. In this case, I obviously didn't solve any questions, so it's timed me out and shown that I've got 0 out of 25. So the first step to solving this was to actually not try to solve it through the web interface that we just walked through. This is an agent orchestration problem, so we've got to stop thinking like a human in order to solve this. So the first thing we've got to actually do is intercept all the data presented to us via the APIs from the server. As we just saw, the browser didn't even have complete information. So we needed some way to access the true information that was hidden behind the site. Now this might seem like a very random challenge to have, but this is how a lot of websites work. A user is going to make a request via a client. That client needs to get the information from the server responds with the data, and then the client makes the interface for the user to interact with that data. But this is a challenge for agents and not for humans. So we can essentially skip the UI part of this and just work directly with the data that comes from the server. So that's how I started this challenge. I started by connecting directly with server data that's coming to the client. From there, we wanted to set up our orchestrator agent. So our orchestrator agent was going to be the primary agent which handled all of the sub-agents. The sub-agents had different tasks like capturing the problem, submitting the problem, verifying the solution, and if everything actually passed, then they should actually mark the challenge as complete. Now, what we found out after a couple of attempts was that the questions weren't always the same. In fact, there were over 90 algorithms in this challenge. So we needed a way to create a bank of solutions as we attempted to solve them. The problems were presented in such a way that even if the same algorithm was shown, it was worded differently or used somewhat different parameters. But it was important that we had seen them in most cases, especially for the competitive problems. Some of these competitive problems also needed solutions that weren't actually readily available through searching the internet or algorithm databases. So we needed our agent to come up with more unique solutions to those problems if they did appear. So after a few runs, we had a bit of a loop going. And that loop was to start the challenge via the API, capture all problem data, identify any missing algorithms that we haven't solved yet, write or complete the new solves. Hopefully at this point would be close to a 25 out of 25 score in the 60 seconds. If not, we would try to continue to solve it in session and ultimately pass the test. If we weren't able to manage to solve it in that direct session, we would continue to solve for that algorithm until we believed that our answer would be accepted in a future session. We would then repeat that loop a few times, gaining increasing confidence that we were going to pass the test. And that's ultimately what the solution was. This was an orchestration problem, not an algorithm problem. We needed to build a pipeline around logging the questions, routing those to known questions or unknown questions, validating our answers, retrying answers that failed, and ultimately doing this doing this in an environment that was penalizing us the more we tried. So very similar to how the real world might work, where you might only have so many attempts at doing something online before you're going to get rate limited or blocked as spam. And it's certainly something that you're not going to achieve if you're using ChatGPT or any AI model as a search engine. Treating AI as an agent orchestrator is going to let you do things well beyond anything you are personally capable of doing. And that's really evident in level 2 of the challenge, which was the Explore challenge. This was another 60-second challenge where we only had to answer 10 questions this time. So in this challenge, we're given 2 large code repositories, in this case, PostgreSQL and Chromium. There are other projects that could appear like Firefox or LibreOffice, and there's really no way you could figure out how to answer these questions as a human trying to search through these code bases in the time limit that it's given. Maybe if you're an expert who's spent thousands of hours inside of these code bases, you might have a chance of trying to search through them manually to come up with the answers, but that's not what this challenge is designed for. And because these are 2 large code repos, it's not something that we can just ask ChatGPT or Claude or even Firecrawl in a sense. Similar to the previous challenge, we wanted to run the challenge 1 to 3 times in order to get a sense of what we were working with. So can we start the challenge, look at the data that's being sent to and from the server, and start saving that locally? We're trying to ultimately give our AI agent memory and an expectation of what's going to be in this challenge. So we ultimately do that by implementing a logging system to say, hey, what did you see? What did you try? What do we think can work? And if something's going to fail, can we solve for that failure type so that if it comes up in the future, it's not going to repeat as a failure? And within maybe 2 runs, we were able to figure out that there was a limited bank of projects like PostgreSQL and Chromium that were going to appear here. So if I refresh the page, we can see that it's now asking for Firefox and Chromium. Equally, once we start the session, we can see that there's a system of questions or a list of questions similar to what we had before in challenge 1. But in this case, we've actually got access via the API to almost the entire general question bank. And those questions are going to be manipulated in such a way to make sure we just can't store the answers like we did kind of in the first level. But very similar, in this case, 10 questions only. We can input the solution, check it, and ultimately submit that. Through submitting some answers, there are also some nuances to the formatting. So sometimes it wanted an exact answer. Maybe it was only the final segment of an answer or a character count. So it was all very kind of nuanced to solve for. And that's why an agent is really good, because while humans are reading these questions or those questions that we just saw, we're going to want to intuitively actually give the correct answer. Whereas an AI agent is also going to hold in mind the expected solution at the same time. So essentially, the pipeline for our agent became capture the question, clean the question, match the question to any in our question bank that we've seen before, get an anticipated answer, check the requested format for the answer against the answer that we think we've got, transform the answer into the correct solution, validate the answer is actually what the system expects, and then ultimately submit. And similarly to level 1, there was an adversarial part of these questions where there were fake system prompts and injections, which we ultimately had to ignore. And figuring out how to get our agent to just remove the prompt injection text versus the question text was part of the challenge. And in real life, you're going to see more and more of that as these agents get better, where companies are going to have to build systems where prompt injections are going to look different every time, and you can't just say to your agent to ignore prompt injections, because people trying to manipulate, hack, or gain access to your AI are going to be more and more sophisticated over time. So this challenge took us about 4 attempts. The first attempt was just about knowledge gathering, so I think we scored 1 out of 10. Got that pretty quickly up to 8 out of 10, 9 out of 10 on the 3rd attempt, and then 10 out of 10 on the 4th attempt. And that's like any good AI system. It's not going to be 100% working out of the box every single time you work with AI. It is pretty magical and it does get a lot of things right. But as you use AI beyond it being a search engine, you're going to have to run a looping mechanism for your AI to improve the accuracy of the task that you're trying to have your AI achieve. So again, our winning approach for this was to build a fast local answering system. We use the API directly instead of using the browser. We're capturing session questions, we're cleaning out adversarial text, we're matching questions to known questions and answers in the past, we're reformatting, and we're validating before submissions. In a real business, I'm thinking something like this would be really helpful in a support desk environment where you've potentially got tens, hundreds, or thousands of questions coming in every day on a data source that is unique to yours, and you need your responses to be valuable depending on what the user has asked. And that brings us to our third and final challenge, which is the build challenge. So if Orchestrate was about coordinating agents, Explore was about finding and extracting the right information, then build is about using agents to create or modify something correctly. So if agents can inspect a system, understand what needs to be changed, make the change, test it to see that it works, and ship it, that's going to be amazing. And that's what build is all about. So in this challenge, we're given 120 seconds, a starter file, and a language to solve for, with 25 checks that we've ultimately got to pass. So the code has to compile, it's got to meet the required functions, maintain state correctly, handle edge cases, and pass performance tests. It's much more akin to having an agentic coding partner rather than using your AI as a search partner. And once again, we didn't want to solve this like a human by just running this challenge. In fact, that's not going to do us much good. If we start the challenge, there's not much we can actually do here as a human, right? So this is where it becomes an agent challenge where we essentially need to build a direct API harness that can extract the data, create the code, validate the code, and submit the solution. That's what the workflow is at the top level. And well, I don't know if this was in the spirit of the challenge, but what I realized with this is that we could rotate the challenge prompts inside of essentially a fixed set of prompts to ultimately get a favorable challenge for us that actually seem more solvable. Now, that's not going to work on every web system that you're trying to build for, but there is something to using AI to put you in a favorable situation based on the challenge that you're trying to complete. So once we saw a few challenges and inspected what the specs and what the expected solutions might have looked like, we were able to define our core agent loop. So once again, our core loop looked something like using the API to generate the full specs of the question and the session data, copy, adapt, and adjust any code to our solver templates. If those solutions existed in the templates, we could rework them back into the challenge questions. We can then validate those answers directly through the validation API. And if that validation passes, then we can rest on that question. And if it failed, we can continue working on that specific question or check until it passes. And ultimately, this took us 3 attempts, where the first attempt we pretty much got 1 out of 25, second attempt 22 out of 25, and finally the third attempt we got 25 out of 25. So even if you've watched this video now, I do highly recommend taking this challenge because you're going to learn a lot. You're essentially going to start to try to work with AI to design loops rather than a back and forth Q&A conversation where you're using ChatGPT as a search engine. That's why agents are so powerful. Essentially, you have got the ability to make highly scalable systems that do things faster than you or I could ever complete them. And what's better is, and what's even nicer is that you can do that with incomplete information. You can do it with adversarial inputs, time pressure, and changing tasks. AIs can adapt and they can learn. It's not about generating the perfect prompt. It's about capturing data, building memory, routing tasks, generating solutions, validating those solutions, and ultimately getting to a passing state. And if it doesn't, it's got to be able to learn why it doesn't. It's got to learn from those failures and improve on the next try. Like I said earlier, like I've said many times through this video, we're not perfect and neither are our agents. But our agents, they can learn a lot faster than we can. So hopefully this video was a little bit a little bit of inspiration for you to take your AI journey to the next level.